Okay, this is the 1-4 creating and solving inequalities. This one is a relatively short video. So we're going to look at section 2-4 in the textbook, and it's 1-4 for assignment purposes. Solve linear inequalities using one variable. First of all, the definition of an inequality is a statement that compares expressions that are not strictly equal by using one of the following inequality signs. So again, we're going to reiterate, and this is a great table for everybody that's having issues with inequalities because it shows you not just what the symbol is and the meaning, it also shows you what you should be drawing whenever you see that symbol. So less than is less than. You should be open hole and shading everywhere to the left. If you look at the less than sign, it kind of looks like an L. So if you take your left hand, hold it up, that's my left, it looks backwards on the screen, and squeeze your fingers together, that makes a less than sign. And then you have an open hold. If you're drawing it on a graph, you get a dotted line and shading everywhere to the left. So greater than is greater than, you have an open hole, shading to the right, dotted line, shading to the right. Less than or equal to is a closed hole, like a fist, and sliding to the left, or to the left because it points to the left, and then solid line shading to the left. Greater than or equal to is solid hole shading to the right, solid line shading to the right. And not equal to means that there is a hole, but everything else would be included. So you'd have on either side going off into infinity, but in the middle you'd have a hole. Okay, on a graph, that would be a dotted line where the graph is surrounding it and coming close to that line, but never touching it. So it would also be a dotted line or possibly a hole. Okay, distributed property we've actually been using during the last couple of assignments, but just to reiterate, it's where if you have A times parentheses B plus C, you can distribute it using what we call the double rainbow and multiplying A times B plus A times C. So here is a couple of algebraic and numeric examples. If you have 5 times parentheses 4 plus 3, you could say 5 times 4 plus 5 times 3, and that would be the same answer. 3 times x plus 3, 3 times x plus 3 times 3. Negative 3 times 2x and negative 4. Here's where you want to put negatives in parentheses so that negative 3 is distributed inside a parenthesis multiplied by what's inside, and a plus stays between them. And then you multiply them to check your, and then change your your negative if need be. Okay, so solving an inequality. We're going to do it the same way we did before. We're going to do the what, why, and our thoughts. First of all, I see a number outside of parentheses, so I know I'm going to be distributing. Distribute the 4/3 times 6. 6 times 4 is 24 divided by 3. That's where 8 came from. 4 times 9 divided by 3 is 12. That's where that came from. So this is all just simplifying at this point. Now we have an equation. So everything above that was just a regular old getting ready for math, getting ready for algebra. This is algebra at this point. Now we're going to do the first step. Well, our first step is I see a plus sign. Add means we subtract to solve. So we're going to scratch out A, pick S for subtraction, subtract both sides. Then we have 8x, which means times. We're going to divide to solve. So we scratch out M and pick D, divide out 8. And then because it's an inequality, we have to then do one more step. Once you're done and you know what x is related to, we first have to check only for inequalities. Did you divide by a negative? So on this last step you just did, when you brought this over, was this division, what you pulled over, divided by, was that negative? If it is, you have to flip the sign. If it's not, the answer stays the way it is. So in this case, it was positive, answer stays the way it is. Okay, so let's do you have a couple of your turns. Go ahead and work this work out on your notebook and then pick your answer. Okay, so a real quick thought is that you might want to rewrite the 1/4 x as x over 4 to make it a little cleaner. And now we're going to look at our thought of what we should have done, or what we're doing, and then our reason why we did it. So first thing, I see parentheses, so my thought is distribute. Then I see a minus, so I'm thinking add. And then I see a negative on top, which means I can move that negative down to join the 2. So it can pop down. And then I look at, well, I have division, so I need to multiply by -2 across. And then I need to check, well, I did divide or multiply by a negative, so now I needed to flip my sign over. So instead of being greater than or equal to, it's less than or equal to. Okay, problem 2. What was this one? Okay, so here's our thoughts, our what, and our why. So again, I see a parenthesis. If I see a parentheses, I think distribute, then simplify. Then I see a minus, so I'm going to go across difference. I scratch out minus and do what I'm the opposite, which is add. Then I see times, so times means to divide to solve, so I divide by 3. This time the 3 was positive, so there's no change. I don't have to do any flips. Okay, so my final answer should be x is less than -3. Okay, real quickly, just to kind of get you into what you're supposed to be doing. So on problem 1, it says Max has less than 3 carrots, C for carrots. Make sure you read this because you can't just use X this time. You must use the C. So we're going to do C is less than 3 carrots. So he has less. Max is him, and he has 3. The number of carrots he has is C, and that's less than 3. So that's where that came from. And just to double check, that is correct. Okay, number 6. And this is a problem when you're going to solve, so we'll look at an example. And again, you can switch onto the example anytime you get stuck, and then you can try again. So we have parentheses and something outside of them, so we're going to distribute. That's where 1/2 times -2 became positive or negative x. 1/2 times -14 became -7 because 14 was negative, 1/2 was positive, so that's negative. 8 times 7 is 56. 8 times -8 is -64. So that's where they got that. And then we're going to simplify things and get everything is on one, all the x's on the left and all the numbers on the right. So they did the x's first, the numbers second, and then they divided. Now, on that last step, they divided by a positive, so the symbol did not get switched. Okay? If you have any questions for 1-4, please let me know. I have after school tutorials and I have the virtual office hours. Where is